Hello everyone, this is Nick Mason. I'm going to be talking to you today about one final piece on Josue's amazing map commentary. The title of this last section is called Interpreting SatWater Data. So I asked Josue if I could add one final piece to his commentary to talk specifically about remote monitoring equipment, the SatWater equipment that we're installing, to talk a little bit more about the technical side, where Josue is focused on community development. I'm more focused on the engineering and technical side of the map. So just to kind of go through this last section together, it should be understood that the map displays data from two sources. The first source is data from the pump. So the pump collects a lot of data from all the reports that are submitted to it. But in addition, we also pull data from our remote monitoring units, the SatWater communicators. So they successfully, when successfully installed, transmit data directly from the installed equipment. And that data can also appear on the map. Now, it's very important that that everyone understand that before that can happen, our current system setup is that there needs to be two prerequisites to get the data to show up on the map. The first prerequisite is to fill out a SatWater report annex. This form is Appendix 19, so it's attached to the commissioning report, and it is submitted at the same time as the commissioning report. This form is fairly straightforward. I can definitely help you, or someone else here in Charleston can help you if you have any questions about this form. The top section is related to the SatWater meter, which is kind of the go-to standard for all safe water projects. This meter is associated to the project, so you fill out the project name and the number. You fill out the serial number on the SatWater communicator, that's the box with the satellite modem, and also the serial number on the water meter. That's just nice to have extra information about the meter itself. The meter has a pulse output, so generally the meters that we use have 10 gallons per pulse, but some of the larger meters use a 1 gallon per pulse. And also there are potentially other types of meters that could use liters, cubic meters, cubic feet as their volume or flow units. So getting all that down on this form and submitting it on the pump will then allow you to set approved alerts for this specific equipment. And just to kind of let you look into some other things here, the water level section talks about the water level sensor, the ORP sensor, and the pressure sensor are also on here. And we're going to talk a little bit more about those. And then once you fill out this form, you are good to go with that prerequisite. I would say there are a few little tricks here. The serial number on the communicator, it's important to put SN dash before you put the 3-digit number. So that would be serial number 170 on the communicator. The form will be rejected if it is just 170. So the correct form is SN-170. That's just a little bonus information. So let's get back to the commentary. The second prerequisite is after the pump receives a SatWater report, approved alerts for the data, for the type of data must be set up. So this approved alerts has already been discussed, so I'm not going to go into that too much. But I'll talk about different alerts that are available for each sensor type. So the most common form of SatWater data, as I mentioned earlier, is flow data. So on the map we have a lot of different alerts that are associated with flow. the most common, or most common that I use at least, is the no usage alert. So I'm going to go ahead and open the map and we can kind of dive into the no usage alert. Here we have the map, and we have a lot of projects, as I mentioned, that that appear. You can see total project number down here is 279 projects on the map. But if we just want to see projects that have active SatWater communicators, we would need to filter those. Not every project on the map has remote monitoring with a SatWater unit. So if in the commentary, I describe the process. The easiest way to view flow data on the map is to filter the map using the no usage alert filter under the accessibility alert types filter. So you go here, you click accessibility, select no usage alert, and then update the map. So I'm going to do that for you guys. You scroll down here on the right on the filter tab, no usage alert, update map. So now you can see that the total projects has dropped to 141. So currently we have 141 projects that have SatWater reported. There may be some that are in implementation phase, they've been installed but they haven't been reported yet, and my hope is that we'll eventually get to getting those on the map as well. So you can see kind of clusters of projects in our country programs. I'm going to go ahead and zoom in on Malawi. You can see most of them are green, and there's some red going on. Basically, these colors are directly related to the no usage alert only. So if we zoom in and look at Mchoka, this is kind of very impressive project. You can see it's got very good consistent data over a lot of I guess the average here for the most part. If you look at the lifespan, it's over 20,000 liters a day. If you look at the last few months, 28, so close to 29,000 average. So just to kind of explain what these bars are, each day has a bar associated to the amount of water that flowed through the SatWater meter. If you hover over the bar, it will tell you exactly how much. So for this most recent transmission on September 23rd, it showed a production of 33,122 liters. So that's how you would read that. And as I kind of demonstrated, you can pull the window of the data back to its first transmission. I'm going to kind of pull it all the way back here to show the first day, 10,751 liters was transmitted on March 17th. So I'm deeply encouraged that through the lifespan of the project, the flow rate has increased. I think that is pretty awesome, and correlates fairly well to what I believe is successful. You can see there was a 3-day span where maybe the system went down and no production happened, or maybe that was a intentional choice to do maintenance on the system. Whatever the cause, you can use this to kind of get a good feel, almost a real-time feel for the production of the system, which also closely correlates to the system's well-being. So diving, you can also see some of these dashed lines. If you zoom down here, you can look at kind of the legend. The legend has question marks. So this actual production, the blue bars represent the quantity of water, as I just mentioned. The gray bars indicate a day where the SatWater communicator missed a transmission. So in this case, the communicator is set to a 3-day transmission. This means that the communicator stores data for 3 days worth of days, And then on the third day, it transmits basically those three values to the database, and that's when the map updates. So sometimes it'll miss a transmission. This can be for a lot of different reasons. A lot of them are related to the telemetry of the satellites. So if it misses a transmission, the totalized value is not lost, but maybe the daily value is lost. So basically the totalized value over those 3 days will be averaged. So you can see here that these gray bars are flat because the totalized value has been divided by the amount of days where the transmission was lost. And so it gives you an idea, but you don't put as much stock in these values because you know that based on everything else, these values vary. So the actual production would probably look similar to these if we received that transmission, but because we didn't, we are averaging it. And you can see over here, the last 2 days have this missing transmission symbol. And if you hover over the question mark, the most recent transmissions have been missed. Gray triangles will be replaced by bars when the next reading is received. So the hope is that because this is set on a 3-day transmission, that tomorrow the data will be received and then these triangles will be replaced with the actual data. And the 3-day transmission, just to explain further, is a way that we save costs because we basically pay by transmission. So we store 3 days worth of data and then transmit every 3 days, which means 1/3 of the cost, which is a great way to save some money. So the dashed blue line you can see is a 30-day average. The dashed orange line is a 14-day average. These are kind of just extra ways to measure and track how production is doing. These are also set in the approved alerts, so you can go in there and change the number to figure that out. And the big dashed line, I like to look at that to get a sense of the daily average. So that is kind of the window, and you can also look at the total, how much water's been produced over the lifespan. Again, I got into that. I'm going to go through that process one more time. Clicking on the project, and then clicking on the graph. And that's how I got this image. You can scroll through here and look at some of the other alerts that have been mentioned by Josue. If you scroll down to the technical sustainability section on the alerts, you can look at different graphs associated with the SatWater meter. So the low usage alert, this line was set, I guess, 25,000 liters as a comparison reading for the high, and then something very close to 0 was used. Looks like something around 100 liters. I can't really tell. Maybe 500 liters was set as the low, and then so that's part of the approved alerts that you can play around with. High usage alert, low usage alert. The low usage can be helpful if you want to track if the production has dropped to something consistently. So if it's dropped below 500 liters for a week, it will basically trip the alert. The high usage alert is a little funny. This high usage alert looks like it was set 25,000 liters when they're consistently producing more than 25,000 liters. This isn't necessarily a problem. So in my opinion, I think I would set this high usage alert comparison reading to something higher, or even just turn it off because it's not as useful. Low usage trend and high usage trend, it looks like these alerts have been turned off, and those essentially would give you an alert if something spiked or if something dropped significantly. You also have this low battery alert, which will be tripped, or it would say battery is not good or poor when you get to a point where battery life is being depleted. So it will give you an alert, and then it will probably very quickly change to missing transmission, because when the batteries die, the satellite modem is unable to send any more data, which means you will start missing transmissions. So if you see this change from good to bad or poor, then it's time to go out and change the batteries. We haven't really had this happen much, but this will help you track when it does. So that is the portion of the flow data. I've kind of talked about how to select the project, how to open the flow chart. So again, Mchoka is an example of good data. When the data is transmitting consistently, it will look something like this. So this makes us happy to see this data. This line is put in here. It's important to check flow data observed on the map with actual data that you're collecting in your monthly follow-up reports, just to see if there are any major discrepancies. There is potential error that can compound, but in general, it's expected that the flow data will match closely to the actual readings that you're collecting from your monthly follow-ups. So we're going to go into two other cases of interpreting the data. Sometimes flow data will come in and look like this. So no production. When the communicator is not receiving any pulses from the flow meter, the data will look like this. This means one of two things. Either the water system is not flowing and water production actually is 0 liters per day, or there's a problem with the meter counter or cable connected to the communicator. So it's important to quickly verify whether no production data is accurate by calling the operator or sending to the technical team to assess. I can't stress this enough. If you start seeing zeros, then we need to verify quickly whether this is accurate or whether it's simply a problem with the meter. We have had some cases that the meter is the internal magnet of the meter has become disconnected, and it's important to just call, say, get someone to look at the meter if it's spinning and the numbers aren't moving, or if you can see that no gauges are actually moving, but you know that water is passing through the meter, then you will need to change the meter. If numbers are moving on the meter and the gauges are moving and spinning, then you would start to look at the cable connection, because there's still a chance that the meter is pulsing without any problems, but the pulses aren't getting to the communicator because of a break in a wire or because of a poor connection made inside the communicator. So those are kind of the ways that you would troubleshoot this scenario. And again, this could be accurate, and it could lead, or it could show you that there's a problem in the community. They aren't pumping water for other reasons, financial reasons or community development reasons. I would also say that our Charleston staff is available for any support in troubleshooting. We've developed some troubleshooting documents for these type of scenarios, and if you need these troubleshooting documents, just reach out to us and we can provide that support. So moving along to the second scenario, when the communicator is unable to transmit a signal, the data will look like this. Again, the triangles represent a missing transmission scenario. So when this happens, it's not a problem with anything but the communicator box. The communicator box may be having problems with transmission for several reasons. Often the problem can be related to a battery issue. So if the modem doesn't receive power, or the internal hardware of the communicator doesn't receive power, then it can't transmit successfully. Checking the batteries inside the communicator with a voltmeter and replacing the dead ones is the first step. Data will also look like this if the communicator switch has been turned off. We've seen this happen before accidentally. They install the communicator, but they forget to actually turn on the power to the communicator. There's the internal switch. Sometimes people forget to install batteries in the modem or forget to install batteries in the hardware below the modem. Or sometimes an overhead obstruction will be created from something other than the water system, and this would inhibit transmission. So for further missing transmission related troubleshooting assistance, refer to the troubleshooting document and or call us and we can help you through those scenarios. So moving along, the other form of SatWater data that we've developed and are confident with is the water level sensor data. So similarly to the flow data that we've just gone through, water level data can be viewed on the map for any project that has a water level sensor. Water level data can be displayed several different chart types, and we're going to go through these alerts that are available on the map for water level. The easiest way to view projects with water level sensor data on the map is to filter using the low level alert. That's my go-to. I'm going to open up the map here. So zooming back out, again, this is all the projects with flow data. I'm going to go ahead and get rid of that filter, go to technical sustainability, and select the low level alert. Now that that one is selected, I'm going to update the map. And you can see we only have a few of projects that have water level sensor. Some of them are trials, and that's why this one is in the ocean. But our most recent installation is in the Haiti office, so I'm going to go ahead and select that one. The default graph that shows up is the no usage alert, but if you scroll down to the low level alert and select that alert, it will open up a different chart. So I'm going to go ahead and explain that one. I'm going to click on the graph here and it opens up this chart. So what you see here is actually the water level data overlaid on top of the flow data. This can help give you some context to potential reasons why levels are fluctuating. So what you see here is two graphs. The water level sensor in conjunction with the communicator will collect 2 measurements a day, and that's why on a given day you see 2 data points. These data points correlate to the maximum measured level and the minimum measured level from that day. So the sensor measures how much water is above it, or the overpressure. The sensor is theoretically installed at the bottom of the well and measures the water above it. So the maximum water level would be what we would define or assume as the static water level. When pumping starts, theoretically the water is drawn down unless the aquifer is very stable, and we would then infer that the minimum water level that the sensor collects during the day is the dynamic water level. So you can see that the blue here is static and the orange here is dynamic. The nice thing about this chart is if you forget everything I just said, you can actually click on a data point and this graphic will pop up and give you information that is a combination of information you recorded in the SatWater report annex form. So on that form you give the pump depth and the sensor depth that has been installed, and you report, and everything else actually is calculated. So the static water level and dynamic water level in relation to the pump and the sensor depth are there. So you can see here 5.5 for the static, and it draws down a little bit, 6.8 below ground during pumping. To exit out, you just click outside that, and again you can pull the range to see different things. This graph to me would signify that this is a pretty stable aquifer. There's not much drawdown during pumping, and there's not much variation on days where pumping was greater with pumping that was less. So there's not a lot of correlation there. But it would be nice to see this over the course of a year and see if any change in the dynamic or static water level is observed over the course of time. This is especially useful data for just verifying how well a aquifer is doing. Any monitoring in the borehole is great to just feel better about the security of the water source and the quantity that you're able to get out of it. So just again, in summary, the gray bars are production from the flow from the SatWater meter. These little circles would say no production, so no pumping was recorded on that day, and then you have two y-axes actually, the well depth, 0 being the ground surface, and you can see that the numbers on the y-axis increase as they go down. So this is 20 meters below the ground. So that's how you would read it, is the the static here is just below 5 meters below the ground, and then the dynamic is down here to 6.6. So on the right side, this will give you the y-axis for the flow. So you can see max was around 6,000 liters per day on that day. This day, 3,293. So two y-axes, a little tricky to read if you aren't familiar with that, and then the days are here on the bottom. And then the pump depth here is, you can actually faintly see this dashed green line. That's just kind of poor placement of that line, but that is also there. So just wanted to thoroughly explain that. Some of the other graphs that are available for level, the absolute low level is here. That would send an alert if there's a comparison, or two low level alerts there. An absolute low level is actually when the water level reaches the sensor. That would trip the absolute low level. There's a short-term static level drop alert and a long-term static level drop alert, and that would basically be if something in the aquifer drastically changed over a short period of time, and the static water level started dropping. These would be extreme cases like an earthquake, or an industry nearby started pumping water and drawing down the aquifer that you were using for your project. So these can be turned off if you don't feel like those are realistic, but they're also great to have extra protection and understanding of the aquifer that you're using. I should also say that water level can be used for more than just a well. If you are using a large tank or a water source that might not be a borehole, but something you want to monitor the level, you can also use the water level sensor. It would just be a little different because this is catered when you click on the data to show more of a borehole scenario. So it would be a little bit outside the context of its intended use, but it's possible. Again, Charleston office is available for any help, any support that you need for installation or monitoring or setting up remote monitoring for water level sensor. Back to the commentary. Kind of went through all these things. Again, here's the graph after you click on the data. So just in conclusion, wanted to mention about viewing data from other sensors. So we talked about flow, and we talked about water level. The map is undergoing development to receive and display data from other sensors for remote monitoring as well. These sensors include ORP, pressure sensor, turbidity, conductivity. We have actually installed all of these sensors and played around with a lot of them here in Charleston, and we're willing to take the plunge to start installing them on the field. However, currently viewing data from these sensors is not available on the map, but it's available on our database that's managed by Sunset Solutions. So it just requires special access at the moment, and we're hoping that with continued development with IT and with our engineering staff that we'll be rolling out additional sensors as well. A lot of the groundwork has already been developed, but some of the fine-tuning is still to be done. So I'm sure as things develop, more tutorials and more commentary will be developed for those sensors. So thank you so much for listening, and this concludes the commentary for interpreting SatWater data. Thank you.